Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be covering GCSE Chemistry Redox reactions. Now that's an important topic because redox reaction involves so many different reactions. It's one of those sort of concepts that you need to know and that will help you understand many concepts in the future. So today's an important one. But don't worry, I will try to explain this in as simplest terms possible so that you can sort of apply all of this today to any example that you're going to have to deal with in the future. So, without further ado, let's get started. First of all, what is redox reaction? Redox reaction is a reaction involving reduction and oxidation at the same time. And that's the whole name, redox. Read part stands for reduction and ox part stands for oxidation. It's literally they stuck those two words together and they got the name for redox reactions. That's it. Now, what is oxidation? What is reduction? I think I already covered it in previous video, but just to remind you, and I think this is a good place to put this in, a way to remember what is oxidation, what is reduction is oil rig. Now, oxidation is whenever an element or a molecule loses electrons. Therefore, oxidation is loss. That's the most correct definition for oxidation. I already said it before, but there are many different definitions for oxidation and reduction, but these I'm giving you now are the most correct, most scientifically correct definitions. So oxidation is loss of electrons and then reduction is the opposite. Reduction is when an element or a molecule gains electrons. So that's reduction. Now, so the way to remember this is oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. So that's what redox reaction is. Redox reaction is when we have oxidation and reduction happening at the same time. So that's when one molecule or one element loses electrons only for another molecule or another element to gain electrons. That's at the essence of it. That's what redox reactions are. Now, let me show you how this is going to work. A very good example of redox reaction is displacement reactions. Now, displacement reactions, we already covered those before, so if you don't know much about it, watch the previous video. I mean, I actually think the previous video is a very good introduction to this video, so I'm going to include that in the link below, so smack that link in the description below if you want to see the previous video that will cover displacement reactions and things as such. So, very good example of redox reaction is displacement reaction. Now, what are those? Those are reaction between a metal and a metal salt, where one metal essentially gets replaced. Salt detaches from one metal to the other, dependent on reactivity series, which we also covered before. So, here we have magnesium, which is highly reactive, reacting with copper sulfate to give us magnesium sulfate and copper. So you can see what's happening here. That copper sulfate, that sulfate group, that sulfate ion jumped from copper to magnesium, and now they essentially swapped. Magnesium displaced copper to make magnesium sulfate. That's essentially what happened. So that's what happens on the sort of molecular level. That's what we start with and that's what we end with. But that's on molecular level. However, what happens on the ionic level? What happens when we are dealing with ions? Now, here we are going to start going to it. So what happens with ions? What happens with electrons? What is going on essentially? So again, same reaction, everything's exactly the same, but here we have magnesium with 2 electrons in outer shell which it wants to lose to have either empty or full outer electron shell, depends on the way you think about it. So magnesium wants to lose 2 electrons to get magnesium 2+, but that's potential, that's not what it is. At the moment, magnesium has no charge on it, it's just magnesium, but it wants to have a positive 2+ charge on it, essentially. Now, what happens with copper? Copper is having a charge of 2+, and sulfate ion has a charge of 2-, and that's exactly why they form an ionic bond with each other, because copper ion bonds to the sulfate ion, and the charges neutralize. So that's the situation we are in at the beginning. What happens now? What happens in this situation? At the end, we have magnesium sulfate. So now magnesium has actually a 2+ charge on it. It actually has it now. And sulfate has a 2- charge on it. So, as you can see, sulfate has not changed its charge. Sulfate has not changed, at the end of the day, sulfate ion has not gained or lost any electrons. And that's very important, you will see in a second. However, copper has gained 2 electrons because now it no longer has a 2+ charge. It wants to have that charge, but it actually is copper. It no longer has that 2+ charge because it has gained 2 electrons. Whereas magnesium, as the result of this reaction, has lost 2 electrons. So it no longer just wants to have a 2+ charge, now it actually has a 2+ charge, 2 positive charge, because it has lost 2 electrons. And therefore it's positively charged. It has a 2+ charge from the nucleus. So, as you can see, what has changed, ionically speaking, or in terms of electrons? Magnesium lost 2 electrons, whereas copper gained 2 electrons. So magnesium was oxidized and copper was reduced in a single reaction at the same time. That's what happened in a single reaction at the same time, and therefore that makes this reaction a redox reaction. So, just to simplify it here, I took away the potential charges. Now we have so that's what we start off with, magnesium, and copper is 2+, sulfate ion is 2-, and then what we end with is magnesium 2+, sulfate is still 2-, and copper is in its sort of elemental form, original form. So copper has gained 2 electrons and magnesium has lost 2 electrons as a part of displacement reaction, because magnesium is higher in the reactivity series, so it displaces copper. That's to summarize displacement reactions. Now, so this is what happens in terms of ions. How do we express that in ionic equations, or sometimes called ionic half equations? How do we express this properly? Well, this is how. So what did we say? We said that magnesium lost 2 electrons. So to start ionic equation, first of all, you put down the element or the molecule in its original, in its sort of initial form. At the same way as here, we start with this, we end with this. It works the same way here. We start with this, and we end with this. So the first step is to just put down what state is the starting molecule or element. Magnesium is in its elemental state. It doesn't have any charge yet. So that's what we put down first, magnesium. Then magnesium reacts, and then we put down what happened at the end, just the same way as we would with normal reactions. Now, so what do we see here? We have a magnesium losing 2 electrons. So we put it down like this. Magnesium 2 plus, because now magnesium has a 2 positive charge, plus 2 E minus. That stands for electrons. So as you can see, that everything balances here charge-wise, because 2 plus, 2 minus, and here we have a 0. So everything balances out charge-wise, and it makes sense. It shows us that magnesium lost 2 electrons to whatever, in this case copper. So how do we do the other side of this redox equation? So here we covered oxidation. However, we need to cover reduction as well. So now we have copper Cu2 plus. Why Cu2 plus at the beginning? Because that's how we start here. The order stays the same. That's very important. So we start with Cu2 plus, and then we have 2 E minus, 2 electrons from magnesium. And that reacts together to give us copper in its elemental form. So that's how you do ionic equations. Now, there might be some confusion as to how to write these down. So that's probably the best way to sort of remember how it works roughly. So with oxidation, you sort of split it into Mg2 plus 2 E minus, or 1E, or whatever. And in reduction, you do the opposite. You start with those two. You start with the element, the ion, and you start with electrons, giving you the element at the end. So that's what most ionic equations will look like. And again, I cannot repeat this enough. The most important thing when you try to determine ionic equations is to stick with the order. Don't mess around. First of all, write the ions as they are at the beginning, and then write the ions as they are at the end, and then figure out the electrons, where you're going to be putting those sort of extra electrons floating about. So that's how you do ionic equations. So this is it for today, guys. I hope this video helped you immensely. If you think this video helped you, give me a big thumbs up. If you want to stay up to date on daily, I try to release daily math, science and biomedical science videos, smash that subscribe button below. If you have any questions, shoot me a question in comments. I'm more than happy to help you out, guys. Thank you very much for watching my videos. I really appreciate when you guys watch my videos. Thank you, and see you again.